Hello, in this video I want to talk a little bit about consumption and production, when we have international trade. Of course, uh, if we have no international trade, then whatever we produce is what we will be consuming. Or the flip side, whatever we want to consume, we have to produce ourselves. All right. So the key thing for international trade and the benefits from international trade is this notion that you can produce a different bundle of goods than you can consume. And therefore, since you have different, countries have different abilities, resources, and government policies, you can specialize according to your advantages to produce the bundle of good that you are good at, but you don't have to consume that. You can consume a different bundle of goods based on what you and other countries are good at and your set of preferences. All right, so I want to talk about these issues, but I want to make it a little bit more specific. So I want to talk about and basically review the indifference curve concept, and then combine that with the production possibilities frontier. And, it is not a secret that some people struggle with indifference curves, or they don't remember indifference curves, or maybe they draw indifference curves in a way that looks like they don't remember indifference curves. So I just want to review that a little bit. So when we're going to go to an indifference curve, we have to start at preferences. And the thing is that, economists, in order to explain the choices that consumers make, we assume that consumers have a set of well-defined tastes or preferences that they use when making such decisions. And well-defined preferences is something that's very strict and technical, and that means that the consumer's preferences satisfy at least three things. These are the three most important things anyway. So one is completeness, second one is transitivity, and the third one is more is better. Completeness just says that consumers can always decide which of two bundles of goods that they prefer. So there are no bundles out there that we have no opinion about. We can always decide, all right, I like bundle A better than bundle B, or I like B better than A, or I'm indifferent between bundles A and B. And we can rank all these possible bundles of goods. And again, notice that you can, a possible ranking is that you are indifferent. Transitivity just means that when consumers rank these bundles of goods, they are logically consistent. So a consumer cannot be allowed, so to speak, to say that I prefer A over B, I prefer B over C, and I prefer C over A. That would be logically inconsistent, so you can't do that. And therefore, rationality is basically this combined completeness and transitivity. So rational people are both have, their preferences are both complete and transitive. And the third one is more is better. And that's just this notion that it's always better to have more of a good than less. At the very least, if you have more of something, you can just choose to not use it. So you can never be worse off from having more of something. Of course, the caveat is that the good or service that we're thinking about's got to be a good and not a bad. So clearly, if the good you're thinking about is pollution, yeah, you can have too much of that. But when we talk about all the regular types of goods that we always talk about in this class, more is better always. All right, so these are the preferences and the assumptions that we have on preferences that your preferences have to satisfy. Now I'm going to just talk a little bit how that connects to indifference curves. I'm not going to go through a whole discussion about preference maps and these kinds of things, but I just want to remind you a little bit about indifference curves. But first of all, indifference curves is what we use as economists to represent the preferences that we just talked about. And an indifference curve is a curve that shows all set of bundles of goods that a consumer views as being equally desirable. So when you draw this curve, and you draw this curve through several different, basically an infinite number of different bundles, all the bundles on that line, the consumer is indifferent between. They view them as being equally desirable. All right, so based on our preferences, indifference curve must have the following properties. So 1, indifference curves farther away from the origin are preferred. That's just a restatement of saying more is better. So as we move further and further away from 0, we get better and better off, right? So our utility increases. Indifference curves are downward sloping. So when you look at this diagram here, it's going to be a downward sloping line. That just means that in order to stay indifferent, if you take something away from me, you have to give me something else in return. That is, one good increases, one good decreases, and therefore this indifference curve will be downward sloping. Third, indifference curves cannot cross. Remember that any indifference curve or any point on an indifference curve means that the consumer views them as equally desirable. If they cross, then there will be at least 2 different bundles where you say both that you're indifferent and you're saying one is better than the other one. And clearly that cannot be the case, and therefore indifference curves cannot cross. All right, so and again, here's our diagram here where we have on the axis one good and on the other axis a different good. And all the points on this I-O indifference curve here, I0, represents bundles of goods that a consumer views as being equally desirable. So A1, B1 is equally desirable as A2, B2. All right, let's go on. All right, so given what I've told you about preferences and indifference curves, here are 3 examples of indifference curves that are incorrectly drawn. This cannot be an indifference curve. Not only are they incorrectly drawn, they happen to be student favorites when it comes to drawing indifference curve. So when you look at this one here in the top diagram, clearly a big portion of this indifference curve is upward sloping. And since every point on this curve says that the consumer is equally, views it as equally desirable, but at the same time, the points up here represent more of everything than the points down here, and therefore you are either violating the definition of an indifference curve, or you're violating the notion that more is better. So they cannot be like this. And this one is the second one, the middle one is of course even worse, because now we have 2 sections that are upward sloping, and clearly this cannot be the case. All right, and again, I see these all the time. And the bottom diagram just shows that here we have 2 indifference curves that cross, which we know cannot be the case. And the reason is, of course, like if I put 1 point here and 1 point there, more is better says that A is better than B, but since both A and B are indifferent to point C here, you can't have B and C being indifferent, A and C being indifferent, and A is better than B. That is, this violates both more is better and transitivity. All right, so we cannot draw our indifference curve looking like this. And again, so what you have to do when you draw these is just draw a shallow upward, or a downward sloping curve like this. All right, don't draw it like crazy. Like, you don't have to draw it like this, or like this, or whatever. Just draw a nice smooth line that is downward sloping. It doesn't have to have a lot of curvature. Okay, All right, now we are ready to think a little bit about indifference curves and PPFs. All right, so now I just want to talk a little bit about the connection between indifference curves and production possibilities frontiers. I know that in intermediate microeconomics, we usually make the connection between indifference curves and an isoquant, basically, where we give up, we can trade inputs in a way that allows us to get a certain number of units of output that we prefer. But here we're looking at the short run when we draw a PPF, and therefore, for example, if you have two inputs, labor and capital, one of the inputs will be fixed, capital, and therefore the Martin rate of technical substitution, which is the slope of the isoquant, doesn't make any sense because one of the inputs is fixed. So you cannot substitute one input from the next. All right. So what we have to use instead is the marginal rate of transformation, which is how many units of one good you would give up in order to have one more unit of another good. That is opportunity cost, which is the slope of the PPFs. All right, so let me just look at these diagrams quickly here. So here we have the diagram for consumption, and we know that optimal consumption will be where the relative price is just tangent to the indifference curve. And since the slope of the indifference curve is the Martin rate of substitution, the Martin rate of substitution must be equal to the relative price. All right, so obviously we can use, calculus or some kind of constrained optimization problem to prove this, but I'm just going to assume that you remember that. So the Martin rate of substitution is equal to the relative price. The Martin rate of substitution is the ratio of the marginal utilities. So if I gave you a utility function, you can take the derivative of good A and divide by the derivative of good with respect to good B, and you will have the Martin rate of substitution. Often, the Martin rate of substitution is equal to the relative price. We can rewrite that, which is basically this equal bang for per buck situation here. So the last dollar you spend on A will give you the same amount of extra utility as the last dollar spent on B. All right, so that's the optimal consumption rule. Let's look at the PPF here. So here I've drawn a PPF. Again, you can see that the axes have both A and B. So we have the same axis in both the consumption and the production choices here. And basically what it says here is that at the equilibrium, the optimum production point will be where the Martin rate of transformation, the slope of the PPF, is equal to the relative price. And what this is, the Martin rate of transformation is the opportunity cost. So basically what it says is that if, where we want to produce is where what we give up to produce the last unit is equal to what we can sell that last unit for, or trade that last unit for. The Martin rate of transformation is defined as the ratio of the marginal costs. I just want to remind you to make the connection between opportunity cost here. In perfect competition, we know that the marginal cost is equal to, again, we're holding capital fixed, so the marginal cost is just a question of labor. So the wage rate times the unit labor requirement, that is the cost, if it takes 2 units of labor to produce 1 unit of a good, if you multiply those 2 units of labor by the wage rate, you will get the marginal cost of producing that good. And the same is true for the good B here. And then we know for perfect competition that the price equals marginal cost in equilibrium. And that's how we get this expression up here. And then replacing by the definition of the marginal cost allows us to write that the ratio of unit labor requirements equal to the relative price. But the ratio of unit labor requirement is the opportunity cost of the goods, and therefore the opportunity costs have to equal to the relative price as well. And obviously, if the consumers face the same relative price as the producers do, then we must be at a point where the marginal rate of substitution is equal to the marginal rate of transformation. All right, I'm just going to talk a little bit more about that in the next slide. All right, so here we have, the first thing I'm going to do is just look at the no trade situation. So when we have no trade, like I started saying in this video, what we consume is also what we produce. And therefore it must be that the consumers and producers will act in a way so the marginal rate of transformation is equal to the marginal rate of substitution, and they are both equal to the relative price. So I want you to look at this diagram here, but I want you to ignore the green lines. So we have a price line, right? And since both consumers and producers face the same price line, so they face the same relative price here, producers will make a choice to find a spot where the marginal rate of transformation is equal to its relative price, and consumers will find a spot, a bundle of goods, where the marginal rate of substitution is equal to its relative price. And since we have an equilibrium, they're both equal to each other. This is the no trade. This is where we would be. Okay? And then when we open up for trade, which is what we do in this course a lot, the reason why both consumers and producers change their behavior is because with trade, the relative price, the trade price, will be different from the domestic or the autarky relative price. Right? And when the relative price changes, then everybody will change their behavior. Right? So the consumers will make sure that the marginal rate of substitution is equal to the new price ratio, and producers will make sure that the marginal rate of transformation is equal to the new price ratio. Right? So just to make it more, a bit more explicit, suppose that the new relative price is that the relative price of A is higher than, in terms of relative B, than it was before. All right? So now when we think about consumers, right? Consumers now have that the marginal utility of A to B is less than the relative price. All right, and if I just change that into the bang per buck expression, we would have this kind of notion. All right, so let me just talk a little bit about what that means. So this implies that the last dollar spent on good A give you less extra utility than the last dollar spent on B. If that is the case, what should a consumer do? Well, obviously, they should buy or consume more B, because every dollar spent on B gives you more extra utility than you lose from taking that dollar away from consuming A. Of course, when you take dollars away from consuming A, you will be consuming less A. All right? So under trade, we know that consumers should be producing less A and more B. All right, I'm going to show that on a diagram in a second, but first, let's think about producers. What should producers do? Well, they're facing the same thing here. So basically what we have here, is that after the new relative price, we have the opportunity cost of A is less than the relative price of A. So what does that mean? Well, it means that in order to produce an A, you give up fewer B than you can sell it for. All right, let me say that in terms of the B good. Because the opportunity cost of B is 1 divided by the opportunity cost of A. So, but basically what we have here is that the opportunity cost of B is higher than the relative price of B. So what that means is that it will cost you more A's to produce a unit of B than you can buy them for. Right? And of course you shouldn't be doing that. And again, just to replicate what I said before, it will cost you more B to produce an A than you can sell the A for units of B. So you should, so then that's something you should do. So basically what we have here is that if this is the case, if the opportunity cost of A is less than the relative price of A, you should be producing more A, and as you shift your resources, which is labor, into the production of A, you have to give up your production of B. And of course, the opportunity cost is how many B you give up to produce one more A. So that's what that one shows. All right, so this is really interesting. So for consumers, they should consumers should consume more B and less A, and producers should be producing more A and less B. So if we go up to the diagram, how would that look like? Well, here we have it. So what this green line, remember, this is where we start. This is where we start. We start producing right here and consuming right there, and then we face a new relative price. In the extreme short run, you might not be able to change what you are producing, but you can still trade. So according to consumers here, with a new relative price, they should consume less A, so they should reduce their consumption of A, and they should increase their consumption of B, right? So we would expect, there will be a new indifference curve that is tangent to the new relative price at a point where the bundle of goods is outside of the PPF, right? You can reach a more favorable bundle of goods than you can produce yourself. This is why we trade. Right, but if we allow for producers to change their behavior too, so we're thinking about the short run, then according to what we had before down here, producers, they should produce more A and less B. So we would expect them to, cut back on their production of B and increase their production of A. So they're going to get, their new production point will be right here. But then, once we know what we're producing, we will still be at a position where we can trade some of our A goods, right, for B goods. So we can reach an even higher indifference curve on this new relative price line. So we can reach a point right there. Okay, again, with free mobility, where labor is freely mobile, we can produce more A and less B, and then we can trade that A, right? So that's our exports, for B, which are imports, in order to reach a consumption bundle that is even more favorable than it was in the extreme short run, and certainly more favorable than when we didn't have any trade at all. Okay. So this is how we think about indifference curves as well as PPFs and how trade interacts through those. Thank you.